Good morning from sunny but cold Vancouver to all of you, and good afternoon in Europe and evening in rest of the world, Asia and even Australia listening to us tonight. I'm very happy to have so many attendees coming to this Advanced Academy. We started the end of February with John Chapman lecture. I did it last year, and now we'll continue every week. We have a special guest and friend, Dusan Simic, from New York, from Analytical Gemology and Jewelry. Good morning, Dusan. Thank you for coming.
Good morning, everybody.
And just to tell a little bit as introduction, while we are waiting for more people to come because we started 1 minute earlier, I met Dusan in 1995, a few days before my trip to New York to study gemology. Dusan was already a gemologist by German Gemological Association from Serbia. From Germany, he was already ready to come to America. We studied together a lot of diamond treatments, and we were lucky to be in New York because these HPHT diamond treatments came in 1999 by General Electric, colorless and 2000 colored, and we were just at the source at the right time, right place. And like for people, Christians or Jewish who are going to Jerusalem or Muslim to Mecca, for us was Utah, Salt Lake City, and Provo places to go, look at the processes and study them. So Dusan was lucky and very knowledgeable to observe processes, but also do his own experiments. So what we'll do now, you will see some of these equipment he was using a different facility, and also you will see how he made his own equipment to do LPHT, what stands for low pressure, high temperature treatment of diamonds. So he was also in few years in India. He also had experience from India and China. And Dusan, if you move to next slide, we can see some of this equipment that you were using or part of your laboratory from New York. We did a lot of education together, of course, visiting different conferences, not only gemological. We went to European research conferences, the B.Sc research by invitation only conferences, but we also learn from different people. I'm very happy that a lot of appraisers, gemologists coming today because it is a very unique process, HPHT treatment, very special, very complicated. And Dusan will try to explain you some basics of this process and also go into details. Of course, for you starting this academy, I would strongly recommend who didn't get it to get our book, Laboratory Grown Diamonds, that we did last year, came out in October. We sold around 1,100 copies in just 6 months, only to our circles. We're still waiting for digital copy and Amazon. We want to still push our hard copy. And we get great reviews, not only by book authors like Antoinette Matlens, René Newman. You can see here it's very accurate source of information, but also from very happy to have a review from magazines like Journal of Gemology that probably all of you know, latest issue, where the beer scientists Peter Lanigan and Colin McGuinness reviewing our book and saying this is extremely useful reference for anyone working in gem diamond industry or having specific interest in growth and identification of diamond. So all this academy, it's about this, to explain you the process of growing diamonds or doing treatments and how to identify. And Dusan will try to do it in approximately 1 hour or less or more. Dusan, please start with your presentation, and thank you for sharing your 20 years experience with us and our attendees.
Thank you, Branko. Welcome everybody, and let's start. I have to say so many and show so many things, and just generally I'll talk about first about the history of diamond annealing, methods for diamond annealing technology used, and on the identification. First, what I want to say that all what I am presenting today, it will be from our own experience, that I did all these experiments, that I choose the diamonds for treatment, and that I used to run these processes. We started together Branko and me before Branko moved to Vancouver, you know, and I was lucky to stay in New York and have a more connection with all this part of our industry. We started with the Phoenix Crystal Corporation. Actually, this is in US the first company that provided the HPHT annealing. It was run by Dr. Bob Frushner and with the way Lee Bill, our old friend, you know, they were first team to conduct HPHT annealing on CVD single crystals, you know. At the time when they opened in 2001, it was really something significant. Unfortunately, they closed facility already in 2004. And after that, we connected with the Suncrest. And Suncrest is so significant for this part of the industry. I will say more about them, how they're great, and how all these people were lucky to work in the factory. It was a part of US Synthetic. US Synthetic is one of the world's largest factory for synthesizing diamond for industrial uses. On the end, actually not when Suncrest Diamond closed earlier because of different reasons, I turned to China and started to work with the Guilin company in Guilin Guiye in Guilin in China. And we did some significant experiments, and I used to sell their presses around the world. So let's first start with the basic stuff, you know. So what we are, how something like this is possible, you know, that we go so high with the temperature, with enormous pressure, and the diamonds are surviving. It is already explained in 1939 by the Russian scientist Leipunsky, when he found this phase diagram for carbon and simply divided by pressure and the temperature, where is a graphite phase and where is a diamond phase. This graph is very accurate. But on the right side, this is a modern graph, and let's just say a few words about where we are providing all this treatments. You know, here is zone catalytic HPHT synthesis. Catalytic HPHT synthesis, it means it is related with the growth of with the HPHT growth of the diamonds, and the area here is approximately from 1500 Celsius, and the pressure is up to 50,000, 45,000 atmosphere. That's the zone where diamonds are growing. But also it is important for annealing, of course, that we are intending to go higher with the pressure and of course with the temperature in order to make this annealing time shorter. It is also interesting to say that and explain what it means HPHT synthesis. It is a function of the pressure and temperature. Let's say the pressure is 120,000. It is much broad, but when under pressure of 120,000 atmosphere and temperature of 2700 Celsius, the diamond will turn from graphite without any catalyst. So it means that this is a way how to create a perfect diamond. About the perfect diamond, I will say more a little bit later. And see, all these graphs are from our third edition, and it will be interesting to read this article for Dr. Boris Figelson and to learn more about HPHT growth. So plastic state, what it means? It is a zone between the solid states and liquid states. This is a phase when the diamond, the atoms in the diamond became movable, but still they keep like a lattice order. And this is the only way how we can create the changes and not destroy the diamond. So right now, diamonds. First of all, we have to know what we are doing, what we are going to change. Today, we are lucky to have really all possible diamonds except natural treated brown. This what also is possible, but then we'll say this is unsuccessful treatment. From brown didn't become white, stay brown. Not important. And in synthetic group of the diamonds, only what is not doable, this is a brown HPHT grown synthetic diamonds. Everything else we have today. And just all of them, they have a different defects. We have to understand all these defects in natural diamonds in order to know what we want to do and what is possible to be done, you know. All these defects could be point or extended. Point, it means they are on the atomic level, and extended means that they are visible, of course, with the naked eye as a color, or in microscope using the different filters, polarizing filters, you know. Point defects in natural diamonds are really, there are many, and so what right now I will not go to this, what could be done by treatment. We'll come to this later. And extended defects actually are much more interesting, because that's why everything with annealing started, because of these brown diamonds. They are, which color is caused by plastic deformation, so caused by external stress when some plates of carbon atoms slip to each other. And this is a defect that we are removing from the diamond structure, you know. Also, here are some vacancy that will be automatically removed, and during the all treatments, some changes on the nitrogen and nitrogen vacancy complexes will be changed. Here, this graph here explain in the, of course, two-dimensionally what is a plastic deformation. So, for example, this empty space is creating this by refrigerancy. Here on the left side are platelets. Platelets, it means that that some atoms are not bonded, and they are in between on the bonded carbon atoms or nitrogen atoms in lattice. Defects in HPHT growth diamonds are most defects are related with the catalyst. They are allowed that the diamond grows and in the lower temperature and lower pressure. This is a nickel, cobalt, nitrogen, also boron is not and here, but it is very popular now as a catalyst, you know. And what is interesting with the HPHT grown diamonds, there is no birefringency, there is no brown color, and HPHT treatments could be used, and I will show later how and the changes, what could happen during treatment. Defects in CVD grown diamonds are much more interesting for us for HPHT or LPHD annealing. And first, it is extended defects. This is strong birefringency, what is creating this brown color, what we are trying to remove in order to increase the final color or CVD diamonds. Okay, let's go first. I will talk first about HPHT annealing. What is a diamond treatment of annealing? Count treatment and annealing as the same thing. Right now, I prefer to call this treatment annealing, you know, because the treatment could involve also some other methods that could help for HPHT annealing, and also to create, or LPHT annealing, and create some other possibility to create different colors, you know. So same thing. What is a diamond treatment? This is one or multi-step process that create changes in diamond structure on point, atomic, and extended visible level. Generally enough. So HPHT, or high pressure, high temperature annealing, is what I'm going to talk first, you know. The main parameters for HPHT annealing is temperature, and the temperature goes in commercially used. It is from 1500 Celsius, where the growth is happening, but also some annealing could be done on the 1500 Celsius, up to 2450 Celsius for very short annealing. Then it is a pressure and time. All three parameters are connected and depends on each other. Especially time depends on the combination of temperature and pressure. Secondary important parameters are, first, equipment. This is the size of the press, size of the pistons, what the defining size of the whole pressure of the whole of the press. Then anvils and blocks. Anvil is things like for cubic presses. There are 6 anvils. They are actually creating this pressure on this piece. This is a block or cell. This is a heart of the whole process, you know. This piece, construction of this piece, but also this equipment is like giving us a final result. Let's say that this block is what is a heart in the human body is defining body temperature. It is defining the blood pressure and also length of the life, you know. Secondary parameter is also quality of use materials. First of all, everything depends on the materials, on the technology, and every day we have more and more improvement. Construction of cell or block is different, you know. So there are so many, because one block, as I show you, could be not like this, you know, but they are different constructions, you know. It could cost $30 to $40, but some of them, they cost also $300. And don't forget that cell could be used only one time, and the rest, what you will say, later goes to the garbage, you know. And finally, the again, we'll come to the diamond as perhaps the main parameters that we have to know what we are doing. So here are different presses. I used to work only with the cubic presses. This is they are picture from China. Here is prismatic press from Nova, also important company from the history. And here is a belt press. There are different presses all around the world. And this is an interesting press. Actually, this is not a press. This is a high pressure, high temperature apparatus, bars, known as a bars. On Russian, it means bespresovi apparatus высокого давления. So it means there is not a pressure inside, or exactly on the English, it is a press-free high pressure setup. And okay, I didn't work on this. I will stay still with the cubic presses. And right now we came to the Suncrest, for me, the most important company that until today used to work with the annealing. We have a freedom, Branko and me, really in EGL USA, really to do so many experiments, you know, and to work really from everybody that were ready to communicate and to give information. We did so many things with the Suncrest. They help us so much, you know. It gave us a possibility to follow diamonds before treatment, after treatment, to learn about identification. And finally, we did also with them this book. It is interesting. I'll say more about this a little bit later, but unfortunately Suncrest closed this facility because simply they were too good, you know, and no one any longer, it couldn't be commercial facility, you know, because they were too expensive, you know. All this annealing moved to India and to China. The prices per carat became lower. Annealing of big natural type 2A diamonds just became not any longer interesting for the different reason. I don't want to go too far about this. And simply for Suncrest to anneal CVD diamonds, it was not commercially successful, and they closed, unfortunately, you know. And we did so many things, you know, so many experience. And one moment when I asked Suncrest, okay, let's now start to do prolonged HPHT annealing, what it means for hours, for days, you know. They told me, hey, this is not possible because, I mean, this is commercial facility, and also the press was not ready. The whole setup, their amazing setup that cost $1 million to $2 million. I don't know how much costs. This press was not ready for something like this. And then I went to China to find in Guilin factory, and this is the first press that I built for investor in USA. It was in 2010. And here I'll show you how it looks to build a facility.
May 25th.
So sorry that the picture is shaking because I'm walking and shooting, and that's how it looks, you know. So there are many things that you have to do previously to check a ground, just to make enough strong pedestal. And this construction happened in 2011. It took from May up to middle of July. And one day came 3 trucks like this, you know, for only one press with a Chinese team of engineers. I'm trying just to reduce. So you see right now construction of the press. Just this construction, when everything is ready, it takes like about 2 weeks, you know. All anvils, there are six parts like this. The weight for a press like this, this is not a, this is like I would say not a small, but rather small than big press. The weight is 30 tons, but also they have a press. This is a 560 press, and there is also existing APHT and 950 presses. They're 60, 70 tons weight. This is a space preparing and preparing for work. Here is a part that is with the ovens for heating, preheating, preparation of the cell. And this part with the press has to be divided and protected from other parts, you know. And right now you see a facility that is ready for work. Huge facility for only one press, you know. And I don't have, but I was there, and you will see in the documentary that is coming more about these facilities in China, where you have like hundreds of the presses, and the size of this facility is really amazing, you know. And yeah, here's the press. Of course, you need to have a crane, just because if anvil is broken and just one has a weight of 30 kilos, you need to have a crane to move it from the press. Here is a computer, and here are different that are giving us possibility to keep a pressure constant for a long period of time, because this press is built for prolonged HPHT annealing. This small press is here because the anvil, we are using this press to remove anvil from the holder. And when the anvil is broken, what is happening? Usually, not often, but if something is wrong with the material, with the casting, you know, of tungsten carbide. And of course, here is spare parts, polishing a unit, and that's how it looks. For example, to build a facility like this, it cost approximately, I think they spent around $400,000. Here I'll talk more about the cell. Cell is as I told you, here is a cell that has 29 different parts, different parts, you know, and different materials, you know, and depends on these materials, and the price of the cell goes from let's say $40–50 up to $300. cell like this allowed me, that we'll see later, to go to make some run that takes for days, but today I'll present one that takes 16 hours. That's how it looks after the run. The cell will look like this. After we break a cell, we will find a diamond that is not burned, luckily, and the process is over. And how it looks, this is a stone before treatment. This is stone after treatment. The surface is, of course, damaged. This is a slight graphitization, and after polishing, we will get a significantly high color. This is a FE color, and we lost for this stone like a half color. From 728 came to 673. But it could happen also. And here is a stone. This is my sample. It happened to me. Here is also that simply the stone can be burned, turn to graphite. Something happened with the cell and didn't work well. And this is what I'm saying there. This is not routine job. You have to take care about everything, and sometimes you cannot control all parameters, And also, it is important to say this is one of the experiments that how you learn stuff. When we try to anneal this rough what Branko brought, from I think Russia or. Okay, doesn't matter. Finally, the color became very high, but you see what left from this, because we never did again rough stone, especially if it's of this configuration, and when it's so heavily with so many defects inside, structural defects, And so we came to this, how to identify. I start to talk about identification. This is interesting stone. It is for us, it was already clear in 2005 that this methods that is a use, presence or absence of a GR1 center is enough to say if the stone is natural or HPHT treated. And I found this stone and made the following experiment. I did an HPHT. This is a 144. This is not a big stone. The budget was not so high, and was a HPHT anneal, and after that, HPHT treated, and after that, I add very low dose of irradiation in order to create a GR1 center. And I send the stone first to DTC, to Maidenhead, and just to tell them what you think about this stone. They identify immediately, I saw that they did experiments like this. They understood, that this identification is not so simple that you will use just a 163 laser, 532 laser. If you see GR1 natural, if you don't see HPHT treated, no, it was over 10, 15 years ago, so. And after that, I sent this stone to big lab. And the first report from 2006, it was a natural color. After that, I spent the time in India. I forgot for this stone, and then in 10,000 2010, I sent again, they sent me again natural color. Then I decided to wait another 5 years, and in 2015, I sent again, and they gave a natural color. Then I sent to another big relevant lab. Also, they gave me natural color. This is almost 2015. And finally, on the end of the 2015, when I sent the stone in Mumbai office, they identified this as a treated color. Why it happened? Here is a explanation. Here are graph. This is type 2A. So when you see, gemologists will recognize also for 1405, hydrogen doesn't matter, diamond peak. Here everything looks usually, Then in the better resolution, we see some single nitrogen. What is a weak indication that perhaps something not okay? But also it could be present in natural stone also. But it is just a warning, Think about this. In UVB is near infrared absorption, but on the room temperature, the graph looks perfect, for the H color. That's how it looks aggregation for H color. But if you check this stone in the liquid nitrogen temperature, you will see C center or single nitrogen that is here created, very small, and also some entry center for 15. Based on this, you cannot make this decision. They are just information. This is something that help you to create the whole picture. In photoluminescence spectroscopy done by 325 nanometer laser, we have a much more interesting information. They are so complex and so mixed that you have to start to think, here something could be wrong. All this entry center, okay, because of this is a Rennie show, this instrument that can produce something like this costs over 300, perhaps today $400,000. That really you see so many things, and entry center, okay, you can accept this. H4, H3, it says, if you see H4 center, you will say this stone is not touched with the temperature, because annealing temperature for H4 center is like 500 Celsius. You can anneal this center just by when you are polishing and when the temperature increase even with the 500 Celsius entry center and also envy centers. So many information, and the most important information here, this is the presence of this line that is a characteristic of centers that is characteristic for HPHT annealed stones. When we go to 514 nanometers laser, we'll see now something that right now, I mean, it's easy to say when you see envy centers, when 637 center is stronger than 575 centers, you will say, okay, this is HPHT annealing. Here is a GR1 center. And this GR1 center is not the same. This created center and naturally occurring center, they're not same. They have a different width. This is a full width. I'll explain this later. But but also at the time, it was like a rule. If you see something like this, this is HPHT annealed stone. But after that, I learned also that, for example, this ratio between envy centers could be changed very easy. That is easy to create 575 stronger than 67, actually to reduce 637, because this is not so stable center, and the first one that will be annealed is 637. I have to say also creation of GR1 center is a very simple things, you know. Even it costs to create this. If I remember, it was like $50, you know, that you can just to create this center, you know. So it means 741 since we did this, you know, is not any longer like main information to make decision. And the conclusion, you know, the features there mainly those associated with HPHT treatments. This is at the time 67 larger than 7510.7 and additional lines and lines at 437 and 477 nanometers. Full width and half magnitude, what it means, you know, just this is a width of the GR1 center, and it could be measured, and this width is larger than it should be in natural stones. And that's it about these stones, you know. About this additional treatment, we try to inform gemologists, you know. It was I wrote an article, and again with the Suncrest supported us, and HPHT treatment, and then what could be problem also. But the big magazine didn't want to publish this, you know, because the reviewer said, okay, we don't want to talk about this, about additional treatment that can create problems, you know, for identification. Of course, because it is not easy to have a lab that costs, in order to create all this information, to have all this information, you have to spend for instrumentation like $400,000 to $500,000, you know. And they didn't publish this, and then with the help with our friend Alexander Zaitsev, I wrote this booklet, and it is available. You can read it. There is much more information. And generally, we are talking about this post-treatment. So right now, go to HPHT treatment of laboratory-grown diamonds. So this is interesting slide, and you will find this in our book. And in the middle, this J color, this is as grown CVD diamond. Interesting birefringency, perpendicular to the growth direction. This stone is not HPHT treated. If the stone is CVD, if they are HPHT treated, but on the way, how, let's say, how they are treated today for the let's say less money, like a cheap treatment, you will get this result where all these structural defects went to the 111 plane. And the most of the stones will show this picture in cross-polarized filters. So it means in cross-polarized filters, when we see this picture, you will say this stone is as grown. If you see picture like this, other 8 stone, you will say they are HPHT treatment. Really, it takes like 2 seconds to make this conclusion. Very, very simple, you know. But if you treat these stones, for example, for 4 hours on 1950 Celsius, this cross-polarized picture will start to be different. You know, not any longer so simple, but still, because it is a tridimensional effect, and it is much more clear if you have this in microscope. When you are rotating a stone, you will see still this defect planes in 111 place. But right now it looks like it could be natural stone like this, but it is not. I'm telling you, if it's alive, you will see this. You know, if we increase time for 5 hours, same, we'll create even we will remove or anneal the much more defects, and the stone became similar to the natural type 2A stone with their birefringency defects. And on the end, but again, even still is visible to see birefringency in 111 plane. And finally, if we treat this stone for an hour, but on the 2100 Celsius, it is something what really, when really CPF is or cross-polarized filters are not enough to say that stone is treated or not, because this picture is so characteristic for natural type 2A diamonds. And that's is a moment when we have to start to use spectroscopy. Here are some 4 samples that I will show different results. You know, first is a HPHT grown diamond is annealed on the 70-50 Celsius for 3 hours, or let's say this is approximately 47,000 atmosphere. This stone before annealing was irradiated in order to introduce more vacancies that will allow the easiest movement of the point defects. You know, so. What was the result? Finally, for 3 hours, aggregation was very small, because single nitrogen in the UV on 270 nanometer is still strong, but in 405 induced photoluminescence, we see creation or 415 entry centers, as well as a creation of H3 centers, vacancy related centers. So it means when people say that like a presence or absence of entry center is enough to say that the stone is natural or treated, it is really not enough, because this treatment is nothing special. You know, this is 1750 for 3 hours only. You know, and still entry center is created. Let's go, and it is done on the HPHT grown diamonds, and what is important, the HPHT grown diamonds are much more stable than CVD grown diamonds. CVD grown diamonds give us enormous possibility to create whatever we want. You know, so first we see again the same treatment that I did on the HPHT now is on CVD grown. Again, aggregation of C center is not so high. 270 is 6 strong. This mistake should be in UV, not in infrared. And again, we have a very similar picture, creation of entry center and H3 center. 4 or 5 induce photoluminescence. But if I put this stone again and on 1950 did additional annealing for 30 minutes, it happened that almost all C center was aggregated. Of course, not all, but it is a lot. And what is interesting that lot of entry centers and vacancy related center is annealed. What will be explained in the next slide. And of course, that the H3 center as a most stable center, vacancy related center is still strong, but still we created the different fluorescence where blue fluorescence is dominating on the green green fluorescence. And here is again CVD grown diamonds that is annealed on 1750 for 16 hours. What happened? That the C center is annealed, not completely, but in photoluminescence, 4 or 5 induced photoluminescence. It is interesting that almost there is some maybe entry center. I mean, this is difficult to say, but we see how like luminescence don't exist. Almost all vacancies for 16 hours are removed. So there is nothing to create emission to give us all this information. It's like it's like a way towards a perfect diamond. We'll come later to this, So, and it was about HPHT annealing. LPHD is low pressure, high temperature. Low pressure means that all treatments are done in vacuum. So it means the pressure is lower than when atmosphere temperature. That annealing could be done goes from 1500 Celsius up to 2900 Celsius, and the main temperature are temperature and time. Of course, no pressure. Pressure is low. Secondary parameters. It is equipment, the height of the vacuum, and also in order to remove air to avoid graphitization, or to use the gases like argon, nitrogen, again to avoid aggregation. Again, quality of used materials is very important, and on the end, the diamond. So here is a press that is built by our colleague and friend Alexander Zaitsev. This is his way how he did the LPHD annealing, and you can try to read more about his using inert gases. This is my press, and I'm using a vacuum. Here is a chamber. Here is a chamber that I'm using. Here is a window, and you see here. This is a pyrometer thermocouple in order to measure temperature, because I did and diamonds survive, treatment on 2900 Celsius, Of course, this is a pulse treatment, and this is amazing picture when you reach 2900 Celsius, the light that is coming is so white, simply it is blowing eyes, And HPHT annealing system, what is a control heating to reach highest temperature on the market? Of course, not 3000, because at 3000 the graphite, what is a small chamber, will start to melt without damage to sample. How it looks. This is a pulse heating. There's a pulse heating. Here is a preheating in the vacuum. Nothing will happen in the diamond. And here this is experience, because on the beginning I burn enough stones, in order to learn how to make a program and how the stones will survive, So each pulse had to take like 2 seconds, and then you can do this as much as you want, So why it was an experiment sponsored with someone, and he has idea to create from the brown 1A stones like a starting material to create pink diamonds. But pink diamonds where amount of the single nitrogen is like the same, to have the same colors, really to make a ring with the 50 pink diamonds where all of them will be same. So this is our friend and colleague Victor Wins. He did the first pink diamonds that we, as the first one, we detected this treatment, and we published this in 2004, and simply you can listen Victor in Advanced Academy. He will talk again about his experiments, what is how you are creating a pink. I'm sure that you know all about this, but just repeat first. You have to deassociate nitrogen to create single nitrogen. After that, make irradiation, and during the annealing, this single nitrogen will be bonded with a vacancy, and this bond is creating a big color. Of course, you have to create enough ambient vacancy in order to make light or intense pink color. So here is the results of this experiment. Okay, this is a starting color, and this is a color after treatment. What happened in the meantime? The deaggregation of the A center, green is before, orange is after, is significant. Here C center is created. You see, here is a 1344 center. How it looks in luminescence. Here is a luminescence imaging before and after. That's how it works with the 1A annealing. This is an obvious change. Here in photoluminescence, creation of entry centers. Why two different graphs? Because one is with a high, one is with a low resolution by high sensitivity. This was in order to recognize the bands or peaks, So, and in the 514 photoluminescence, we see again a significant change in the aggregation like H3 center is decreased or partially annealed. And what is most important, it is NV centers. They are giving us enough information that this stone is treated. It is not enough, but in this case, it is enough to say this stone is treated. Here is another stone, starting brown color and then yellow color. And also I have to say that the brown is not completely removed. There is still some brown, okay? This significant improvement, but not completely brown, is not completely removed. What we see here, this is that the platelets, they are interstitial atoms, they are all removed, you know. Okay, not a big deal. This is not so stable, not so stable center. Also, some decrease in A center, and creation of entry center. And again, yeah, here is interesting that the whole H4 center as also one of the less stable center is immediately annealed, and also H3 center is decreased. Here are NV centers as you prove that stone is LPHD annealed. And the last one, stone, it is interesting again because platelets are interstitial atoms are removed. They are bonded to the lattice. Single nitrogen is created. Here you see much more than in previous, because simply the stones are different, you know. And really, in conclusion, I will say this, because finally the whole experiment was not successful. C center is created. Again, N3 center. H4 center is annealed, and here are NV centers. Just what happened with this experiment, you know, the investor was not satisfied. I used to run like 50 stones, and the results after pink treatment, they were not unique, you know, because it is a natural stones, you know, different. They react differently, you know. So, and he did not decide to go commercially with this project. And unfortunately, because I did this experiment in 2011 or 12, I'm not sure, you know, but I didn't have a chance to work with using this system to CVD, and I'm expecting that like a treatment on CVD will be much more successful, because the brown color in CVD is significantly less stable than brown in natural diamonds. And perhaps I will do this one day. And the summary is that I would say like that the HPHT annealing is the most advanced and powerful method for diamond treatments, and depends on the facility, on the budget. Really, the HPHT annealing has no limits, you know. Really, and theoretically has no limit, you know. And really, this is a challenge, you know. And because of this, it is a complicated and most expensive method. Really, it costs a lot of money to afford to do these experiments, you know. What is important that is HPHT is not routine and never will be routine method. So it means whatever you did, you know, if you are doing something for 16 hours, for, I don't know, 3 hours or 16 hours or 2 days, you know, you have to sit in the front of this computer and watch all the time what's going on and to follow parameters, you know, because the damages are happening in the seconds. If something starts to change on the parameters, you have to press a stop and to try this again, you know. So about HPHT annealing, today is used for the reduction, eventual elimination could also happen of brown color in natural or CVD grown diamonds. And also LPHD annealing is used for color treatment of diamonds of any growth origin. So it means to create pink, to create yellow, blue, green colors. Identification, of course, it is a challenge, you know, and we are saying, and Branko and me, we are promoting all the time that identification is not routine. Identification is not to press a button on the black boxes, what are dominating today in screening, not identification. But someone will say identification, this is not identification. We are saying also that at least 2 identification must be applied if you want to be really professional. And of course, for most complicated cases, the most sophisticated instrument must be used, you know. And it is really easy to say, you know, most sophisticated instruments, because to have a lab that you can identify everything, it costs $500,000 to $600,000, you know. And who can afford this? It is a problem, you know. But let's work on this, you know. And on the end, you know, yeah, let's say just a few words about the perfect diamond. This is a perfect diamond. So perfect lattice, carbon only. What it is, synthetic or natural, you know. And if you ask me how to identify perfect diamonds, I will tell you, I don't know, and I think only one who knows this is this guy on the right side, and it will be end of my presentation.
Very interesting presentation, and explaining quite technical, but also in simple terms, what happened to the diamonds, natural and lab grown, with the HPHT and APHT treatment. First question I have myself, and I'm sure many of us like to know what you can do with the standard instrument, like a fluorescence, UV lamp, cross-polarized filters, to indicate that you're dealing with the post-treated HPHT, mostly enhanced diamond.
Oh, yeah, of course, but this is my standard method, you know, that when something came to the lab, first I will use a loop. Then I'll put on the microscope and I will excite with the standard fluorescence lamp. Already, it will send me towards some direction. And if you are talking about HPHT annealing, what is happening after HPHT annealing, when you are exciting, when you are inducing fluorescence, you know, generally the picture, what we have to see, it's something like a cleaner fluorescence. What it means, natural diamonds, they have many defects, many things are all together creating a mess or something like this. But of course, that HPHT annealing is bringing order inside, you know, removing, of course, damages by refrigerancy, and if you see many stones, you will be able to see, you know, and think, hey, perhaps here happened something with the stone, something like a post-treatment.
Did you publish something like this in any of your books, this fluorescence of different colors of diamond before and after treatment? Can you show us something about fluorescence colors in some publications?
Oh, yeah, but this, I already showed during a presentation. This is a book, and here on the page 11, there are fluorescence of the pink diamonds, and here is a fluorescence of the yellow diamonds. Why I have no here fluorescence of the white diamond? It is because the difference before and after is so tiny, you know, that in the printed version, really you don't see much. Plus, all these stones are type 2A, very, very low nitrogen, no emission. That's the reason why these pictures are not here. But, and even there is a difference before and after. The difference in pink diamonds and yellow diamonds is obvious. Is obvious, you know. So, and this is like I would not say like a strong, medium strong indication that something is wrong with the diamond when you see this type in Yellowstone, this type of fluorescence. And the good in this book is that there are 5 different stones, and you see like a similar change that you can say, okay, this is a rule what's going on inside that can give you like information for where to go, how to start further identification.
So there's a slight increase, a very slight, because entry center is a little bit created after treatment, slight increase in fluorescence and more moves towards violet, bluish, a little bit chalky maybe. This is what you can see, correct? A little bit increase.
This is something, and also, you know, it depends on the treatment. For example, all these stones are treated in Suncrest, and the Suncrest treatment was very short, because they were able to go with a very high temperature because of the technology, because of the press, you know. And in this case, you don't anneal, you are creating entry center, but also you have to know that all these processes are going up and down, you know. If you prolong treatment, in the case that they could run their treatments for hours,
yeah,
entry center will disappear. The all vacancy somehow will be annealed, and the stone will not show any emission.
Okay.
But of course, this is technologically, this is not so simple.
Yes. So you were the pioneer in using cross-polarized filters, and like 10 years ago, you did lots of pictures, and we did the first edition of this booklet, and very well received. So how cross-polarized filters can help in screening and identification, in some case, of type 2A diamond that are treated? Talking about 2A, but especially CVD, because in the book, in our latest book, we put something on that. Can you show us that in the book and explain what's happened to CVD when the post-treated?
If you remember on the beginning 2003-4, when so many people used to bring to us brown stones, tell me type 2A for treatment or not, you know, it was a method to tell them, okay, this is type 2A. Because of the number of the stone, it was much faster to check this in microscope than to put in infrared. You know, of course, we double check if it's okay. This is a procedure, And to use cross-polarized filter in identifying type 2A, it is I would suggest this, and it works perfectly, you know. But if you have already stone that is so high color, like F or E or D, you know, I mean, really, there is no way that you can say based on birefringency, stone is treated or natural. You know? Really, I mean, I would never do this, you know. So.
But on CVD, you're more confident if it's post HPHT treated or as grown. You're more confident to separate, yeah, on CVD.
Yeah, right. with the CVD, it is much easier. And what is dominating in CVD today? For example, that all processes, they are commercial, that producers can pay for them, are not on the level what, for example, Suncrest used to do, you know. And the changes are not so big, you know. Of course, the most of the brown will be removed, but not all of the brown. And also, it is important to say that stability of this color, created color, is not so high as stability of the color on the natural diamonds using Suncrest annealing technology.
Very interesting. In this direction, I have a question from people. For example, what is the effects of HPHT treatment on some center that are causing brown color, or they're part of the brown color, amber center that we know? What you can tell about amber center stability?
It is what on the beginning, in the early 2004-5, we used to in infrared watch first for amber center. Is amber center is present or not? And it was for us a good indication that stone is treated. So amber center related to the brown color will be annealed. This is not so stable color. And today, for me, I mean, I almost forgot that amber center exists, you know. So for natural diamonds, of course, you know. I mean, I didn't pay so much attention on amber center. Today, I don't pay so much attention on the amber center.
But it's just over 4,000 wave numbers in infrared, this center. It's there. 4,000.
Yeah, this is, and plus, we see amber center only using FTIR.
Yeah.
And FTIR is not so sensitive in absorption as UVV's near infrared absorption. And
okay, we have another question. Because you mentioned interstitial atoms and brown color, and what's happening with these interstitial atoms, where they are going after annealing? Because it seems to me they're removing them. Interstitial atoms, they're disappearing, or they're realigning somehow. What happened to them? It's a question.
Yeah, this platelet peak is very characteristic for the brown diamonds, and I mean, this is a they are group of the different atoms, you know. They are not bonded, they are in between because of this mechanical damages and the destruction of the lattice, you know. And after you apply temperature and the pressure, of course everything goes toward the perfect order, you know. And all these atoms, they are in between. Of course, they will find the place on the vacancies, and they will be bonded on these places and to create regular lattice.
Mm-hmm. Interesting. There's one question about pink diamonds, and remember like 15 years ago when first pink multi-step treated came on the market. Actually, next lecture of Victor Vince on May 7 is about that. He's the first one who created this, and we detected, and we published in Rappaport together. So what amount of nitrogen is enough for creation of this pink color with the vacancy during the process of HPHT and post annealing, post radiation? What is the amount of nitrogen, and what is the difference in colors between a smaller amount of nitrogen? And I remember first stones with quite dark, deep red, and then we have more natural looking pinks. What is your you were involved in this research in New York, and with a few dealers, and about pink diamonds?
Mm-hmm. So there is a difference between natural and lab-grown diamonds, and you know this. If you remember, simply the creation of pink, treated pink color from natural diamond never became like a big business, you know. And this is illogical, you know, how you can control, you know, so well amount of the aggregated nitrogen in order to create same color for the, I don't know, hundreds of the stones, you know. What actually it is a business, you know. We remember different sizes, different colors. Colors were nice, out of question, you know. But the problem with this pink was that from natural diamond, it was problem to create like hundreds of thousands of carats of the same color. And finally it came with the lab-grown diamonds, that you can create pink from HPHT grown diamonds if amount of single nitrogen is enough high, or okay, there is there is many things that you have to follow. It is depends. For example, for HPHT grown diamonds, you have to apply irradiation in order to create vacancies. After that, annealing is around 1100 Celsius. After this annealing, if amount of single nitrogen is enough big, the pink will be created. So it means there are few things that you have to follow. First, that the amount of the single nitrogen has to be same in the all stones, what is not a problem, of course. After that irradiation, that apply irradiation is simply fit to the color, to desired color, and after that standard annealing temperature is the same and standard.
Okay.
In CVD, it is different because already you have enough vacancy. You can create pink without irradiation. Just you have to apply annealing, and then the final color depends actually of the single nitrogen.
But generally speaking, the less amount of nitrogen to be lighter pink color. Generally speaking, of course, there are many other factors. Yeah.
Not necessary, because your annealing time could be shorter, mm-hmm. and then you will get a lower. You will get like a less intense pink. But then with the CVD, you have a brown color, you know, and you have to remove this brown color also.
Yeah. Talking about CVD, I have a question that I think because I run the lab here and other labs, US lab mostly, bigger labs, who started to put recently, a few months ago, on their reports that lab-grown diamonds, specifically CVD, if they are exposed to post-treatment process, they will mention on the report. As if you spend enough time, we can separate this. But what do you think, as a person who work in the labs, but also working with the trade, does trade needs this report on the post-treatment, and is it always possible to separate them? And do you think it will happen like a natural diamond, that the consumers and jewelers wants to know everything about the stone, every little step, what is done, how is done on the color? What is your?
I think you know more about this than I know, but I see this intention, just to put everything on the table. And as a gemologist, as someone who working with this, I have nothing else than support this, So why not? Why not? Even though something is very simple, doesn't cost. You don't need to invest enormous money. You don't need to waste time, to show something. And I don't know why people are discussing this, So what means? Do you remember that even in the 2004 or 5, that we insisted in our certificates in EGL USA to put additional graphs?
Yes.
You remember?
Yeah, we were the first to do it.
It was a revolutionary idea, No one accepted this, But right now, for example, when you have a different frauds and the stuff like this, it is every additional information is helpful in order to prevent the frauds,
Even now in CG, I like to put on color stones and color diamonds, specifically spectra, because spectra is like a signature of that stone, very unique. And on lab grown also you can put infrared spectra or photoluminescence. Is very important. So in this direction,
I don't understand. And you remember how it was a simple?
Yes.
Really, no, it's like in a minute you are bringing much more.
I think big labs are a little bit, not say afraid, but very cautious about disclosing how they are finding that this is the treatment or synthetic, because they don't want to raise a second, third question and disclose information, basically share. You and me are sharing a lot in these talks or in the book, but big labs doesn't want to do it. This is a big difference between us as
this is another thing. This is another thing about the standards that I mean, we are talking so much about this, and really, this is not from my point. I mean, I cannot understand, that everything is a secret.
Yes.
Can you imagine the secret?
We can fit the next question in this conversation, because we know, and you talk about this in 2016 at the Mediterranean German Jewelry Conference that I hosted in Spain. You are my speaker just because of that, about how people are duplicating stones who are big and important. And this is a question from somebody: if large type 2A diamonds are under great suspicious when they're post-treated, and we can add if they're lab grown or if they grow them to match certificates. Can you tell us more about? And I think we talk about this. You're insisting on this to talk about this in the book, fraudulent replica chapter. Whole chapter of the book is about that. How especially type 2A diamond, correct?
Yeah, but this is for me. This is not I cannot understand, that no one wants to talk about something that is so obvious, that is so simple. And I mean, I have a feeling that how they are saying, like, who care? Who care? And then I don't know who is paying for this. The consumers. And especially right now, it was I remember, this is from the closed circles, so when GIA decided to call HPHT treated natural big diamonds, when they decided to call them treated, just this business was killed, It was all these companies close their businesses. But what they started to do, and I remember at the time, people used to come to me to ask, hey, what GI will say. And I was equipped at the time with the Rennie show, with all other stuff, and I already understood, their way of understanding things, identifying something like this. So, and then I started to think about this, but also some of them told me, what they are doing, like HPHT treated round stones were most asked. And then I asked, why only round? Why only round? Because, with the round, you can, after cutting, you have one natural round stone of 5-6 carats this size. And after that, you will find HPHT treated. You are cutting on the same way, absolutely same, and you just change them, and then find me next one, next round, go further with this, It was happening in 2010, 2011, something like this.
Yeah,
and right now with the synthetic, with the 1 carat, 2 carat, this is simple,
And it's very naive way to protect trade and consumers by laser inscribing these diamonds. To write HPHT enhanced on the girdle.
What about this?
Or to write
let's keep some.
Right, lab grown. I know the dealer from California who had 3 carat, 4 carat diamonds, and happened the one local guy brought the stone to appraise. We also do appraising, and I see that stone doesn't have inscription, and I see his HPHT enhanced. I said, wow. And it happened that he told me the name of the dealer, and I happened that I know him, a lot of people. I know the guy, and I asked him what happened. Why stone is not laser inscribed? Says even on the report that laser. Oh, I was just sending it to the show in Hong Kong preparing for the show in Hong Kong. So somebody was misinformed. But of course, this wouldn't happen if you have the spectra, if you have more information, you can match it, you can duplicate these results basically. But this is what we would do. But hopefully one day trade will accept some of our ideas, revolutionary, some of them. So another question about detection. And many instruments, not all, many instruments are based on detection on N3 center, which is 4 and 5 line. And most natural diamonds do have this center, and even small or big, that it's a different story. But question is, what is the future of this identification to separate natural lab grown? Because after post-treatment, you also mentioned that there's a small creation of N3 center. And what do you think about future of this detection to separate N3 center in diamonds? Because
I understand. But first of all, we have to say, just to remind our guests that natural diamonds, they don't need to have N3 center. So this is like most beautiful diamonds. They are like a pure 1AA diamonds. They of course they don't have a N3 center. But okay, they are rare. You don't find this as all these Cape stones that really show like a blue fluorescence, stronger N3 center. And so my way, how I would recognize is N3 center created or is belongs to the natural diamond, is by comparing intensity of N3 center with the laser peak. Because just to watch N3 center or any of these peaks in photoluminescence is not enough good. The quality of this information is not enough good, because emission is not a quantitative technique. You cannot measure intensity or single nitrogen or whatever. You cannot quantify this. And simply, what will happen in the future with the entry center? Why I think why we have a entry center, why we see so often entry center using 4 or 5 laser, because the stones are annealed in India, not only in India, in China also. But in order to do HPHT annealing for acceptable price, that is like I think $70 to $100 per carat. Really, you have to use cheap material. What it means, cheap material, that you cannot go with a high temperature, that the time of the annealing has to be a little bit prolonged. What it means prolonged? It means 20 minutes. But if you remember the Suncrest, they used to do this in the minute, 2 minutes, it depends, And this is something else. And this is what is creating these traces of entry center. It has to be known. And after that, of course, that you need to have instruments to see this, to compare, to learn, with the new stones, to follow the changes.
So these traces could be also seen in CVD post-treated diamonds, small entry center showing up in CVD diamonds. But maybe black instruments on the market, the cheaper one under $10,000, will not detect it, because it has to be certain sensitivity, correct, to see this tiny entry center. It has to be good laser, very expensive, system, like a Renishaw or good system, correct?
Some of the instruments they are today available, because if you so how I'm doing, I have 2 spectrometers for one excitation. One is with a high resolution, and another one is with a high sensitivity, in order to cover all possibility what are coming. So it means on the same stone, in one spectrometer you don't see entry. In another one,
I see,
with the high resolution, you see them.
Mm-hmm. This is the issue of standardization of instruments, standardization between labs. What is published in a scientific literature, it's specific instruments in specific labs that are very different in different labs, correct? So we cannot always duplicate same results. Most of the time we cannot. We just can try to see the same defects, but different intensity, different. So I think this is the issue for us and for the gem lab industry, to standardize these techniques, steps. Remember, we tried many years ago to make a system of standardization with different instruments. Never took off, but it was a good idea.
Well, we go so far, but we know very well,
Yeah, but
inside the roof, how many labs presenting them as labs, and they are not lab at all, So this is like eventually FTIR, and then plus some of these boxes. I mean,
I'm very looking forward. I'm very happy that we'll continue with the additional books, mine this next few months on diamonds and different treatments and synthetic, and yours coming up hopefully next winter. That's really will address this issue: how to use different instruments, different type of instruments, but standard way on 100 stones. This is your next project, correct? And we can finish with that because we don't have any more time. We have to finish within half an hour. So just tell us a few words about your next project and how you can address this, what you can show to the trade and to the how you can give them information, educate them on results on different problems, different stones. What is your collection, basically?
Yeah, this is a. I have so many stones, you know, that I collected from different projects, and I came to idea, and of course I have to borrow some stones, and we have a very good sources that will help us, you know, I know they have interesting stones, you know, they will give all this range, you know. What is the idea? Idea is that already I don't have any longer Rennie show, and all information that I will collect right now, this will be like advanced plus information. It means it will be different spectrometers, different very sensitive cameras, of course, FTIR, microscope, and just
cross-polarized filters also. Cross-polarized
filters, of course, you know. And then it will be like 2 pages in the book, one stone. All these pictures, and from all kind of the natural, all kind of the natural color diamonds, imitations, of course,
treatments,
HPHT grown, CVD grown, treated, not treated, just to be like a help, you know. So help what, for example, these optical properties of the diamonds, you know. So this is our right hand, you know. So when we are doing all these measurements, you know, then you are opening, you are reading, you know. Not only this, there are other works written by eminent physicists and gemologists, and it will be like visually. But visually, for the people, they don't need a PhD. They don't need to understand completely, you know, what's going on inside. But at least visually, to be helped, you know, in order to decide on the end what do they have.
I think idea of these 5 lectures that we're giving for free, and I thank you for donating your time to give this free lecture to educate people. Will there have 5 lectures to be fee-based? This is preparation for people, for books like that, to read better these graphs, to understand what this means, these defects. So this is about next book, about this Advancement Academy, to prepare for the 4th, 5th, 6th educational series. So I think we finished most of the questions, and I want to thank you for your time, and we'll finish this educational academy, you and me, end of June with such a lecture on case samples on different stones. Hopefully we'll disclose some of these for the next project.
We will talk. We will show like
examples.
Introduction to the 5th edition. Yeah.
Good. Okay, Dusan, thank you a lot, and see you soon at some other webinars and seminars. Thank you.
Okay. Everybody, thank you for being with us.